Hey guys, this is Dr. Rauf Tailony. We will be talking about the um, operations research course. This course is very useful for the people who are dealing with real life engineering problems, especially related to the processes or process optimization and solution regarding the management and specific resources management and handling. So as an introduction to the something we call it modeling. So when you have a certain system that contains like let's say a production line or an assembly line for a certain product, or even a group of people that are following a certain process to achieve a predefined goal, then we need to create something on paper or on a software that we call a model. So you represent these people or these machines in terms of parameters or numbers to be plugged in, into a certain software or into Excel sheet. In that case, you can look at it, let's say in a 2D form, and be able to look where is the least efficient process or least efficient asset in your system and trying to eventually optimize it. So in this course we will be trying to learn how to build a model for a certain system. We will have several examples for various systems of in specific engineering applications or sometimes financial applications depending on the topic. So let's start with introduction. What is operations research? Some people calls operations research as a management science because you simply use scientific approach to do a decision making so that you can have the best design and operation in your system. And that is usually that kind of decision making have a certain conditions, especially those conditions are tightly related to a limited resources in that system. What we mean by a system is an organization of interdependent components, either independent from each other or depending on each other, or even hybrid, like some of them depend on each other, some of them doesn't, working in parallel in that system. So they work together to accomplish a common goal for that system. So as an example, the Ford Motor Company is a system that have a goal of maximizing the profit, same as any other company in the world. That profit can be earned by producing quality vehicles. So they want to focus on quality so that they can maximize profit. If their profit is minimized, if their vehicle quality is minimized and it's not up to the customer expectations, that of course will reflect on their annual profit. So the goal is to maximize the money, maximize the profit. In order to do that, it makes sense to maximize the vehicle quality to maintain the brand. So all the people, anybody who buy a certain product from this company know that this is a quality product. Internally, you are thinking about how to keep a quality product while keeping your costs as low as possible and your profit as high as possible. So that's where operations research comes in. Basically, this kind of science showed up during the World War II, where the British military leaders in specific, they asked the engineers and scientists to be able to analyze several military problems, let's say like a radar, for example, so that they can manage their all their resources in an effective way without harming their own military health and military resources and so on. So the scientific approach to do a decision making usually accompanied with the use of mathematical models, as we said, to simplify the problem. If you think about the problem just in your head, nothing on paper, there's no kind of certain easy to use representation of those assets in terms of number. As they say, if you can't measure it, then you can't develop it, you can't optimize it. So you want to be able to measure it, you want to be able to see it in simple numbers. That problem, if it's seen in terms of numbers, then you can know, hey, my costs are high, my costs are low. In terms of numbers, that will reflect on all other engineering aspects and so on. First topic to look at in the model building, the optimization models. We can see in here optimization models or the perspective. So we will be having perspective or optimization models. The perspective models usually describes the behavior of the organization so that it will enable the best of it to meet the common goals of that year or that period of time. When you have a perspective model, you have certain components that the perspective models include. So you have firstly the objective function, you have the decision variables, and you have the constraints. So the function is the main thing, how the whole process works. Then the decision variables. When you are trying to do a decision, what are the variables that could go wrong related to your decision, or what kind of variables this decision is tied directly into. Then you have the constraints. Those are the limitations. Do you have like expenses limitations? Like you would love to buy a certain laptop that you love in the market, but your constraints are your wallet. Did you take care of your rent? Did you take care of your bills? Then do you have enough savings for emergency, and so and so? So after that, you can decide if you are able to afford that laptop that you like, or you need to wait more, or even ignore the idea at all. So those are constraints. Those are limitations on your abilities or on the available resources that limited you from achieving the goal or the desire that's in your mind. So the optimization model, trying to find the values for the decision values, for the decision variables that optimize. Optimize means either maximize or minimize the objective function and the final goal among the set of values for that decision variable satisfying the given constraints. So you need to make sure that your goal, your decision variables, and your constraints are all working together, nothing interfere with each other to achieve your final goal without having losses. Then the second one, you have the objective function. So there's an example that we will talk about later. Like let's say there's a company called Daisy. They like to maximize the yield of their process. So in most models, there will be a function that we need to maximize or minimize. That's how the function works. So the function is called the model's objective function. To maximize the process yield, we need to find a certain values that we declared for each variable of that problem. Let's say we have a volume, we call it V, we have a pressure, we call it P, temperature T, ABC, etc. In a lot of situations, the organization could have more than one objective, either working together depending on each other or separate. So let's say, as an example, we want to assign students to the two high schools in some place in Indiana, but the board stated that the assignment of students involved the following objectives. So firstly, you need to equalize the number of students at the two high schools. So between the Indiana High School and the Monroe County School, you need to make sure the number of students admitted to those two high schools are the same. You need to minimize the average distance of students travel from school to home. So you want to take care of the how far the students live from that certain school. Then having diverse students body at both high schools, trying to diversify the ethnicity of students admitting on both schools. So those are constraints. Those are things, let's say goals, and some of them are constraints. Like you have a goal to have equal number of students in both schools, but you need to minimize the average distance for each student from a school. You want to choose which school is better for him and closer to him. Then you want to have the diversity goal in your mind. That is a goal and could be a constraint as well. So we will discuss more problems and do some kind of mathematical modeling and clarification based on solution for similar problems in the future. We have as well a topic called the decision variables. So the variables which values are under our control, we influence the performance of the system. Those we call them the decision variables. We will have an example that declaring the decision variables, where are they, how to find them, and how to define them and assume all the needed parameters for them. Then you have the constraints. As we mentioned, constraints are basically limitations. What is limiting you from achieving your goal, or what kind of limitations that I want to take care of to reach my goal. Let's say I'm driving my car from home to work. There's constraints. When you drive, let's say on the highway, you have on both sides of the road. That's the limit of the road, right and left. Then you want to take care how many cars are around you, on what speed those cars are, then what is the speed limit that's needed on this road. Those are constraints. You keep them in your mind. You keep your speed lower to the legal speed limit. That's one constraint. While you're going to your goal, you still can't overspeed. So you need to be in the certain required speed for that road. Secondly, you want to make sure you will not crash with other vehicles around you. So that to keep in mind, you want to be in the right lane at the right moment, and so on. Eventually, while taking care of those constraints, you need to reach your goal in a reasonable amount of time. So in most situations, only certain values of decision variables are possible. So let's say you have volume, pressure, temperature for a physical problem or a physical process. The combination could be sometimes unsafe. So those are constraints. You can't mix material A, B, and C, or physical value A, B, and C. Or if you increase the value of A, the value of B will be decreased, and so on. So those are examples of some limitations. So you have like volume must be between 1 and 5, pressure to be 200 to 400 millimeters. Those usually a lot of engineering problems involving those things. Like you have a certain temperature that you can't exceed, you have a certain mixture that you can't do, or you can do, or you need to do, etc. So those constraints, you can put them in terms of mathematical representation. So you made the assumption for that certain parameter. You declare, officially declaring that you are assuming V for a volume, let's say, and based on my physical properties or constraints, I can say that the volume should be less or equal to 5, and the volume, since its physical value can't be 0, so it's either equal or higher than 1, pressure, etc., temperature, variables A, B, and C, and so on. So you just define those before you start to solve your problems. Those are part of the modeling. Like when you declare assumptions for the values and you are putting constraints, now you are already in the process of modeling. What you do next, you solve that model and you do the optimization. Either you do maximize or minimizing the problem. So we can see here there's a value called Z. We are trying to maximize Z, and we combined a certain constants with certain parameters. So solving that, maximizing Z, solving that equation for the highest value for Z will solve the problem while keeping in mind those constraints. That's it for now. Next time we will have some examples, like simple examples on how to do a model building and how to imply operations research in your real life engineering, physical, mathematical problems.